Hi, I'm Dr. Nick Enger at the Fenner School of Environment and Society at the Australian National University. And I'm here to give you a quick introduction to a cool new data sharing campaign that I'm funding through my Australian Renewable Energy Agency funded research project. What we're doing with this research project is actually building solar forecasting and modeling tools for distribution networks. We're predicting the availability of solar radiation and therefore PV power generation ahead of time and giving this to them in an operational product. One of the things that we get to do with this research effort is actually build, modify, update satellite-based solar radiation modeling tools. We're using the new Himawari 8 satellite, which has unprecedented spatial and temporal resolutions, 1 to 2 square kilometer spatial resolution and 10-minute interval updates. What this allows us to do is actually model solar radiation estimated actuals, as we call them, at the Earth's surface over all of Australia in a way that's never before been possible. We capture cloud trajectories and approximate opacities to model surface available solar radiation, including global horizontal irradiance, direct normal irradiance, and diffuse horizontal irradiance. One of the things we're doing with this data is actually making it available through an API, an application programming interface, which means researchers like yourself can access this data with an ease and rapid accelerated access process that really makes it all so easy you can't say no. So what you actually end up doing is signing up, registering for this API, ticking that you'd like to use it for research and development purposes as you go through that registration process, and bang, within 5 minutes you're able to access high-resolution solar radiation data looking back 7 days in the past. The other thing you're able to do is access our solar forecasting technology as well, where you can look from 0 to 7 days out at 30-minute intervals and see a live forecasting product that updates every 10 minutes. So as researchers using these types of technologies, it gives us an ease of access to solar radiation data and forecasting tech that's not really actually been available for research in this manner before. And what I see as being really important with making this easy to access and giving it to other researchers is that really the forefront of enabling the future grid, where the electricity transformation in Australia needs to go. All of that is oriented around when the sun will shine and how brightly, and when it will be interrupted by clouds. Fast-moving cloud bands moving over South Australia, creating 200 to 300 megawatt demand shortfalls because of the rooftop solar PV dropping its power output suddenly, scream opportunity for energy storage, demand management, and smart inverters to do something about it in an orchestrated fashion to enable this future grid transformation. And that's precisely the type of thing that we as researchers at Australian universities need to be working on to make this thing happen. So in thinking about how I could best collaborate with my researchers, I've decided to put out this enabling solar data tech. And I hope it's something you find very useful and look forward to getting your feedback on how it can be improved to suit your needs as researchers. Look at the data page, get registered, and start using the API. It's so easy, even my 3-year-old son could do it. Well, maybe with a little help. See you on the API. Look forward to seeing what you come up with.